All right, we can dispatch this problem fairly quickly. This is another problem on calculating z-scores and thinking a little bit about their meaning. So it says that in the population of all IQ scores, that that population is characterized by having a mean of 100 and a standard deviation of 16. And then it says further that the IQ score for Einstein was purported to be 160. Okay, and let's call that X, a data value within that population of all such data values. So it asks four simple questions. The first one it asks is, what's the difference between Einstein's score and the mean? It's asking for a simple difference. What is X minus mu? How far away is this data value from the mean? And the answer is it's 60 points. All right. The second question is, how many standard deviations is 60 points? Easily answered, because the standard deviation is 16. If you want to know how many standard deviations 60 represents, you divide it by 16 and you get 3.75. And the next question says, well, then what's the z-score associated with this X? Well, that is the z-score, right? The z-score is just exactly that. It's the number of standard deviations that a data value is from the mean, or from its mean, and in this case it's 3.75. And the final question says, well, is this an unusual value? And the answer is that if z is greater than or equal to 2, then the X associated with that z, the data value associated with that z, is considered unusual. Okay, and I wish I'd written that a little differently. You really have to write this if the absolute value of z is greater than or equal to 2, because z can either be greater than positive 2 or it can be less than negative 2. And in both cases, the X would be considered unusual. And so that means that Einstein's IQ would be unusual. Einstein's IQ would be considered unusual. Okay? Enough.